Sir, you have only 10 minutes for presentation and there will be 5 minutes for question and answer.
Good morning. Today we are going to present our chemistry project about design of 2.45 GHz RF receiver in CMOS 45 nanometer technology. So before going any further details, I would like to request all my team members to use themselves. So myself, other persons with us, right? So myself, other person, this is from so those are the overall flow of our presentation and our table of contents. So I would now discuss about why our project matters. So in this project we are working with radio frequency signal, which is ranging from 3 kHz to 300 kHz. So those are the foundation for our wireless communication. But in this project we are especially targeting 2.45 GHz signal, which falls under the IC band. So IC band is globally licensed. That means we don't need any special permission or cost to operate in this frequency. Also, now it is widely used in low power application. So, in the era of wireless communication, we always continuously searching for compact and power efficient RF receiver. So, the front-end design of RF receiver directly impacts our signal clarity, signal sensitivity, noise tolerance, power consumption, and other events. And now, by using 45 nanometer technology, we are aiming to design a chip-level integrated solution. Now, in this slide, we mention some of the real-life applications about the data. If we talk about Wi-Fi, Bluetooth, or GP, or 4G AD system, all those systems operate in 2.45 GHz. Here we mention our project objectives. So now I want to describe how our RF receiver will work. So for this we have to look at this block diagram. First we will use a bandpass filter which will isolate our 2.45 GHz signal. Then we feed this signal into RNA which will boost our weak signal. Then by using a local oscillator, we are making it to a baseband and high frequency signal, and by using low pass, we are extract our desired baseband signal. So we are planning to design and simulate those by using cadence. So that's it from my side. Now I will request my next team member to continue the program.
Thank you, Mr. Shekar. I am I will be presenting now the literature that will guide our RF receiver design. So our RF receiver design consists of four design platform, which is the bandpass filter, low noise amplifier, mixer design, and low pass filter, which is initially designed for our architecture. We designed. Then we selected 3 recent papers closely related to our both. So in this paper, we can see we did not follow their full architecture. Rather, we gained some invaluable insights into how this block will be designed in terms of our RF system. So in this slide, you can see the Rajavi 1992 paper, which actually did this block diagram, and then another paper which is from 2006, and then the 2005 paper, which is the transceiver system. We can take from this diagram as a reference. Then we can see from these 3 papers, we can find some findings that they are showing us some lower power consumption, and in some areas they cannot provide fully high noise performance, and their noise ratio will be decay, and the power consumption will be lower. So in some areas we have find a gap that they have used some technology like 65 nanometer or any other technology. But our proposal is we are expecting we can do in 2.45 gigahertz and CMOS 45 nanometer technology, which is far better than performance and as a low chip area, which can give us the better performance in lower noise performance. Then this is our proposed improvements, which we can see our proposed was we can make better performance on the LNA, and then we can 45 nanometer technology that I previously said, and our power consumption minimum 20 milliwatt, which can we review previous literature review. We can take this from a reference because they show this they can take minimum of 45 millimeter watt. Then we can propose that we can take this power consumption as 20 milliwatt. Then here is our initial specification design parameters, which can we initially set this, but while doing our simulation and our layout design in cadence, it will be varied. But it is our proposed specification. Now I would like to invite Shatabhushan to continue the rest of the slide.
Thank you, Shubham. Let me explain the methodology for our system design. So our work is divided into mainly 3 stages: first, system design and analysis, and then schematic design and simulation, and third, physical verification and layout. In this trimester or CP1, we just mainly focus on system architecture and planning. So we have identified 4 key blocks for our project, like bandpass filter, low-pass filter, low noise amplifier, and the mixer. And we are analyzing how they connect each other, and we have to learn how to increase our gain, noise, and other parameters. So for our design, we choose a component architecture, and it is also called a direct conversion. In this method, the RF signal is directly converted to a baseband signal with a local oscillator at the same frequency. After that, a low-pass filter is used to avoid the undesired frequencies and also just remain the desired frequencies. It has several advantages, like there is a low frequency problem, and this is a simple architecture and compact design, and it has also a low power consumption circuit. That's why we choose our component architecture for this. In CP2, you will design all these of the block in transistor level by using the cadence virtuoso, and we will analyzing the using the spectrum simulation. Next in CP3, our main goal focus is on design the layout, and we want to verify this by using FDF and DRC technique. So this is our academic project. We will not go through in chip level implementation. This is our limitation, but in future we will make sure that it can be paper or integrated. So that's all from my side. Now I will request my teammate Dharma to continue.
I would like to walk you through some key points of our project. Now, every Capstone project must align some program outcome as well as knowledge profile and as well as SDG. And this is our project is this project introduced. And our project will these knowledge profiles. And regarding sustainability and SDG alignment, our project using these sustainable our project contributes to the sustainable development. Now, and this was our projected time. This was our timeline for CP1, in which we did initial research and focus for RFC work. And this is our projected timeline for CP2, in which we will do the schematic for our specific blocks such as LNA, DTF, DTF, and research. And this is our timeline for CP3, which we will do the and for smooth coordination for the project, we have regular meetings with our supervisors and mentors, and we have given the tasks equally for efficient workflow, and also we have also taken the journey. And for conclusion, if we conclude here, our project focus is to design a low power 2.4 GHz IFC part using 45 nanometer technology. We have started our work initially by researching past papers and decided to go through with the homodynamic architecture, and the blocks of this architecture was previously explained by our members. But we can do some improvements, especially in terms of power usage, system signal quality, as well as noise level.